Yellowstone, Wyoming. In spring 2003, strange things began happening in America's most famous national park. The tallest geyser in the world, which can go 50 years without erupting, burst into life, spraying columns of superheated water hundreds of feet into the air.
There were new cracks in the ground. The ground heated up to the point where the National Park Service had to close some trails.
Not long after, a group of bison collapsed and died, victims of poisonous fumes from below the ground. Satellite pictures revealed that something ominous was happening beneath the earth. On the internet, unfounded rumors spread that a supervolcano, an eruption so large that it only occurs on average every 700,000 years, was about to blow.
These things happen. You can look at the earth and see the scars.
Today, I come before you with urgency, not fear, but with love, not despair. I want to talk about the unmistakable signs unfolding before our very eyes. In Yellowstone National Park, the animals are fleeing, not in ones or twos, but in herds. Bears, elk, moose, wolves, leaving behind the only land they've ever known. This is not folklore or conspiracy, it is observation. Nature is often the first to recognize the subtle rumblings that we, in our distraction, ignore. Beneath Yellowstone lies a sleeping giant, a supervolcano, and friends, it is stirring.
The last supervolcanic eruption occurred 74,000 years ago. An explosion so large that it could wipe out a civilization. But what makes a supervolcano?
Supervolcano generates the biggest explosive eruptions that we've ever seen.
A single supervolcano explosion is 1,000,000 times bigger than Hiroshima. No ordinary volcano comes close. Regular volcanoes eject millions of cubic feet of ash and debris. Supervolcanoes eject billions. Regular volcanoes can throw ash over an entire state. The ash from a supervolcano could blanket half the United States. Supervolcanoes are real events. Over 20 have been recorded in the history of the Earth, and over half of these happened in North America.
Imagine a situation with worldwide famine.
People will be literally burnt to a cinder.
The results will be catastrophic.
We could be seeing 1 billion people dead. We could be seeing the start of a breakdown in the social fabric of the planet.
Part 1. Yellowstone's hidden tremors and fleeing animals. And the early dawn of July 2025, Yellowstone National Park stirred with an unsettling rhythm. Herds of elk trotted nervously through pine forests, bison stampeded across the open Lamar Valley, and coyotes abandoned their dens in an unusual exodus. Dozens of animals were seen fleeing deeper into the wilderness, away from steaming geothermal basins and the watchful eyes of tourists. Scientists from the USGS.
In July of 2025, a series of unusual events began to unfold in and around Yellowstone National Park. Thousands upon thousands of animals, including elk, bison, deer, and smaller mammals, were reported to be moving toward higher ground. The mass movement, captured in countless videos uploaded by park visitors and researchers, quickly went viral across social media platforms. The strange behavior of the animals has sparked widespread concern and speculation, particularly among those familiar with Yellowstone's complex and active geology. At the center of the concern is the well-known fact that Yellowstone National Park is home to one of the largest active supervolcanoes in the world. Although it has not erupted in many thousands of years, the very presence of such a powerful geological feature has always been a topic of both scientific interest and public unease. When animals begin behaving in ways that seem out of the ordinary, especially on such a large scale, many people begin to worry that the Earth is trying to send a signal. Reports of seismic activity in the region have increased in the last few months. According to geologists monitoring the area, several low-level tremors and ground shifts have been recorded in recent weeks. While none of the activity so far has been large enough to trigger official warnings, it has been enough to draw the attention of researchers. Some have suggested that the seismic changes may be influencing the migration patterns of wildlife, pushing them away from familiar feeding and resting grounds and toward the higher elevations of the park. The sudden and visible movement of animals has only added fuel to online theories and public speculation. Some individuals believe the animals are responding to subtle environmental signals, vibrations, gases, or temperature shifts that human monitoring equipment may not be sensitive enough to detect. Others have gone further, suggesting that this could be a sign of a potential eruption from Yellowstone's supervolcano, despite there being no confirmed scientific evidence supporting such a claim.
The Yellowstone warning signs. Seismic activity. Earthquakes in the region have increased in frequency and intensity. Swarms of tremors are being recorded, a possible sign of magma movement.
Yellowstone is a unique place in the world. It's best known for its hydrothermal features, which is the name we give to hot springs and geysers and steam vents or fumaroles. All of these features are indicative of the great amount of heat that is pouring out from the interior of the Earth to its surface.
30 times more heat pours out of the ground in Yellowstone than anywhere else in the Rockies. Scientists had always assumed that the heat came from an extinct volcano that died long before the last ice age. Then, on August 17, 1959, a major earthquake changed that view forever. The quake triggered a giant landslide at Hebgen Lake to the west of the park. 80 million tons of rock broke off a mountain and crashed down onto a campsite. The quake killed 28 campers. 19 of their bodies were never found. It was the deadliest earthquake to hit the mainland United States since 1933. Since then, Yellowstone has become a laboratory. Geologists covered the park in seismometers. When they examined their data, they found Yellowstone averaged over 25 earthquakes a week. It was the most seismically active area of the United States outside California. But no.
Watch their monitors flicker with unease. In just 48 hours, over hundreds of small earthquakes rippled beneath Yellowstone's Norris Geyser Basin. The seismic swarm ranged between magnitude 1.2 to 3.8, creating an underground orchestra of cracking rock, shifting magma, and trembling.
Just before a volcanic eruption, the signal produced by regular earthquakes would give way to a new signal, a long, continuous vibration.
Now, when magma's opened a space for itself, it will start to move through that, and as it moves through that very rapidly, it will vibrate the walls of the crack or the conduit, and that will give you a sort of rumbling signal.
It sounds like the vibration of a large organ pipe. Scientists call it harmonic tremor. It's the last warning. This is what magma racing towards the surface might sound like. For anyone brave or foolish enough to remain in the hazard zone, the chances of escape would be slim. The Big Bang would be moments away.
There's ground deformation. GPS measurements show the land is rising and falling. pulsing like a heartbeat deep below.
Bob Smith grew up with Yellowstone. He had his first job in the park 50 years ago. He's gathered evidence that suggests that our worst nightmares about Yellowstone could be true. In the 1970s, he was revisiting Yellowstone Lake when he noticed that the landscape had changed since he was last there.
Trees just at the edge of the lake seem to have water in the root systems and been inundated by a few inches of water.
Strangely, this only occurred at the south end of the lake. Bob came up with an extraordinary theory. He suggested that the whole north end of the lake had risen, pushing the water to the south. To check his theory, he organized a new survey of the land which hadn't been surveyed since the 1920s.
We went to the old benchmarks that were set up along the highways by the original road surveyors. The surveyor said to me, well, these people really have made a big error, these people in 1923, because I'm off from them some like 18 inches to 2 feet.
A thorough check revealed that the original survey was correct. This meant that between 1923 and 1977, the center of the caldera had risen over 2 feet. But that wasn't all. New surveys in the last 10 years revealed a further surprise.
Lo and behold, the ground was going down between basically 1995 and 2000. So we were pretty excited because it gave us this idea that it's dynamic and it's truly alive. This is really kind of a living, breathing caldera.
It looked like the volcano was still active. But could this amazing discovery be true? Naked Science tracked down a scientist who has crucial evidence that supports Bob's theory. That evidence comes from people who died centuries ago. For over 11,000 years, Native Americans lived around the lake, hunting the bison that came here to drink. The primitive weapons they left behind reveal the position of their settlements. Archaeologists have collected these arrowheads and mapped their locations. The arrowheads show that the native villages moved back and forth 6 times over the last 15,000 years as the edge of the lake rose and fell. The rise and fall of the caldera shows that the volcano is active. That makes it a massive ticking time bomb. Several miles beneath every volcano is a magma chamber, an area of molten rock. In the case of a supervolcano, the magma chamber is huge, tens of miles in diameter. When the pressure in the chamber gets too great, the magma erupts, and the ground above collapses into the partially empty chamber, creating a giant depression in the earth, a caldera.
Dimensions of the magma chamber were at least 50 miles long by about 25 miles across.
The caldera was enormous. The whole center of Yellowstone Park had once blown out and up. This was the site of an incredible eruption, one so large that it must have affected the whole planet.
Yellowstone National Park, renowned for its breathtaking landscapes and geothermal wonders, is now at the center of a potentially alarming geological development. Amateur researchers and avid watchers of the park's live cameras have observed a large bulge forming beneath the park, sparking concerns that a significant geological event may be brewing. A group of dedicated amateur researchers, who regularly monitor the live cameras set up around Yellowstone National Park, have reported a disturbing anomaly. These enthusiasts noticed the emergence of a dome-shaped bulge beneath the park's surface, a phenomenon that seemed to develop over several months. Intrigued and concerned, they began to systematically document and analyze the changes they observed. To substantiate their claims, the researchers collected and compared photographs from several months ago with more recent images. The comparison revealed a noticeable increase in the bulge's size and prominence. This evidence suggests that the ground beneath Yellowstone is rising, potentially due to magma accumulating in a subterranean chamber.
Gas emissions. Changes in carbon dioxide and sulfur dioxide levels tell us that molten rock is creeping closer to the surface.
Hydrothermal pathways out then, with a thunderous roar. Steamboat Geyser, the tallest active geyser on Earth, erupted without warning. Its colossal plume of boiling water and steam rocketed up to 360 feet into the air, dwarfing nearby pine trees, spraying scalding mist across the basin, and echoing like a distant cannon through the valley. Visitors gasped in awe and fear, while geologists at the USGS headquarters in Denver held emergency consultations.
Should Yellowstone erupt, it would not be a local event, it would be a global one. The immediate effects: pyroclastic flows, blistering waves of ash, gas, and rock traveling at 100 miles an hour, devastating everything in a 100-kilometer radius.
Within an hour of a Yellowstone supereruption, pyroclastic flows could race across the countryside and engulf the valley of Jackson Hole and the town of Livingston, some 50 miles away. Within a 60-mile radius, 90% of any remaining people would be killed. A few might be blown to pieces in the initial blast. Most would suffocate in the heat of pyroclastic flows. But this would just be the beginning. The power and fury of these pyroclastic flows are awesome. But they're nothing compared to what would spew forth from a supervolcano. To see what happens when a pyroclastic flow hits a major town, Naked Science visited Plymouth on Montserrat.
We're just coming into the capital city of Montserrat, which was Plymouth, and it has been hit by pyroclastic flows and devastated in 1997.
David Lee witnessed the flows that hit the town. The experience is seared in his memory.
At the daytime, they look like a gray mass. You wouldn't even think they were dangerous, although they're moving quickly. At night, they are totally on fire, totally incandescent, just glowing, and you could see them sweeping down over the city, and everything they touch, because they're probably 500 degrees or more, just bursts into flame. Most of the population was up on the hillsides, as close as we could get, and you could see the whole city burning.
Once, over 4,000 people lived here. Today, it's a ghost town.
A supervolcano generates the biggest explosive eruptions that we've ever seen.
Geologists measure eruptions using the Volcanic Explosivity Index.
It's a little bit like a volcanic Richter scale, and it runs from 0 up to 8.
At level 1 are tiny eruptions throwing 350,000 cubic feet of ash into the air. Level 2 eruptions are slightly bigger, like this blast from Mount Etna in Sicily. This volcano in New Zealand, ejecting enough ash to fill 58 football stadiums, is a level 3. The 1883 eruption of Krakatoa in Indonesia was a level 6. A supervolcano? Make that level 8.
Each point on that scale represents an eruption 10 times bigger than the one below.
Mount St. Helens was a 5. A super eruption is at least 1,000 times bigger. But what factors make supervolcanoes like Yellowstone so explosive? The answer lies in the type of magma or molten rock that triggers the eruption. Quiet volcanoes, like Kilauea in Hawaii, have a very runny magma called basalt. When the magma reaches the surface, any gases trapped within it escape gently. There's no violent eruption. But the magma beneath Yellowstone is completely different. It contains larger amounts of a substance called silica, which can bind vast quantities of explosive gas into the magma.
If you combine that binding phenomenon with lots of gas, then you have a recipe for a really big explosion.
There's ashfall. A suffocating blanket of ash could smother much of the U.S., collapsing roofs, contaminating water, grounding flights, and killing crops.
But what will happen next as a mountain of ash begins to spread and then fall? The Yellowstone supereruption could throw ash 15 miles into the atmosphere. The fallout could cover half the United States. 3 days after the eruption, the skies would be dark and deadly. From scientists' predictions, Naked Science has pieced together a picture of the country after 3 days of ashfall. At 6 times heavier than wet snow, wet ash would cause many roofs to collapse, clog up filters of cars, and ground aircraft across much of the western U.S. Any planes in flight would be in danger of crashing, their engines clogged by the fine particles. When Mount St. Helens erupted, swirling particles of ash in the atmosphere generated lightning, which in turn ignited scores of forest fires. A supervolcano could ignite hundreds. The worst affected region would be the downwind area up to 500 miles from Yellowstone, as far away as Salt Lake City and Denver. Carried by the normal prevailing winds, the ash would reach Denver in about 24 hours. By the time it had finished falling, it could be deeper than 3 feet. Within this zone, no movement would be possible for 2 days. Roads would be invisible, and people outdoors would not be able to see where they were going. Transportation would come to a stop. Winds whipping up the ash would create dust clouds, and people stranded in the open would likely suffocate within hours. Moist ash collecting on power lines would short insulators, cutting off power. If it happened in winter, then the cold weather would take more lives. Falling rain would wash ash into rivers, creating giant mudflows called lahars, smashing everything in their path. Pumping stations at reservoirs would be clogged with ash, leaving many people without fresh water. Nuclear power stations dependent on cooling water from rivers would be forced to close. As with the aftermath of any catastrophe, lawlessness could take over. Livestock could die from lack of grass and water. Hospitals could stop running. The old, the sick, and the very young would be even more vulnerable. In this central zone, up to 10% of the population, or 500,000 people, could die. A supervolcano isn't just the world's biggest bomb. It's a bomb that throws smaller bombs. To see what sort of bang it would make, you need to compare it to the largest man-made explosions ever. This is the most powerful bomb ever detonated by the United States. It's the Castle Bravo hydrogen bomb, set off on Bikini Atoll in 1954. But at 15 megatons, it's still 160 times smaller than a supervolcano eruption. This is the world's biggest bomb. In 1961, the Soviet Air Force dropped a 50 megaton bomb over Novaya Zemlya in the Arctic Ocean. The mushroom cloud rose above the stratosphere, and the shock wave traveled 3 times around the Earth. Imagine an eruption 50 times bigger than this, and you have a supervolcano. Any way you look at it, that kind of eruption would be a very nasty surprise. The blast of a supereruption would be awesome enough, but it's nothing compared to what would follow. Spreading out from Yellowstone would come one of nature's most deadly forces. Violent churning clouds of rock, ash, and gas called pyroclastic flows.
Pyroclastic flows are the nastiest of all volcanic phenomena. They are blasts of fragmented magma, hot ash, incandescent gases that travel at hurricane velocities, and they blast out across the ground surface in all directions from the eruption.
It's like an avalanche on steroids. Hidden beneath the turbulent cloud of scalding hot ash is a mass of tumbling rocks. At temperatures as high as 1,500 degrees Fahrenheit, it sweeps down the mountain at high speeds, destroying everything it touches. There's nowhere to run and absolutely nowhere to hide.
The volcanic winter. Sulfur dioxide would reach the stratosphere, blocking sunlight and plunging us into a multi-year volcanic winter.
Scientists agree that what made Tambora such a killer was the 200 million tons of sulfur dioxide it pumped into the air.
These tiny droplets are spread worldwide by the stratospheric winds, and they produce a veil that covers the Earth and cuts out some of the sunlight that's coming in, so that the sun actually appears dimmer. And so less sunlight is warming the Earth, and it's natural then the Earth cools down.
This dimmer effect caused the famine of 1816. By some estimates, Tambora killed 71,000 people, twice as many as Krakatoa, mainly through starvation. It's the deadliest volcanic eruption in recorded history. A supervolcano's effect might be even greater.
The effect it would have on the atmosphere is much more severe than any of the historic volcanic eruptions like Tambora. And we estimate that the drop in temperature globally after a Yellowstone-sized supereruption would be about 10 degrees Fahrenheit. Now, that is a very severe cooling. Frost and snowfall, and even in equatorial regions. Tropical vegetation has no cold hardiness. So a frost in the tropics would kill off all the above ground vegetation. And in that kind of situation, the climatic effects, the loss of the growing season for 1 or 2 years, it's been estimated that you could lose billions of people from the Earth's population.
An active supervolcano lies in waiting under Yellowstone National Park. If it were to explode, it could plunge the world into a volcanic winter. As the global temperature dropped, millions could die. It would be by far the biggest disaster ever to hit the modern world. It sounds terrifying. But if it happens 500,000 years from now, we're not quite so worried. If it's 5 years, start packing.
The global consequences. Food shortages. Agriculture would struggle under darkened skies and shortened growing seasons.
They believe that the deadliest part of a supervolcano eruption is not the ash that falls to the ground, but the gases that stay in the air. Professor Mike Rampino of New York University investigates how volcanic eruptions in the past changed the climate of the planet. To find out what will happen if Yellowstone erupts, Naked Science brought Professor Rampino to New England. An old tombstone in a New Hampshire graveyard contains a warning of what a supervolcano would bring. It records the events of 1816, a date that became known as the year without a summer.
And this is a memorial to a farmer named Reuben Whitten, who managed to save the town of Ashland, New Hampshire in 1816 by growing enough wheat on his land to feed the community. There was snow in June and frosts in July and again in August that killed most of the wheat in the lowlands, but Reuben Witten managed to grow enough wheat in the highlands here to feed the town.
They were lucky. In 1816, the growing season in New Hampshire dropped from 120 days to just 60, killing the crops in the ground before they could ripen. And it wasn't just America that was affected. Bad weather caused harvests to fail in Europe. 1816 to 1817 witnessed the worst famine in over a century.
There would be economic collapse. The ripple effects would shake economies worldwide. Travel would be halted, exports ruined, and supply chains severed. Environmental chaos. Ecosystems would crumble. Wildlife would vanish. Even the oceans could change in temperature and chemistry. The USGS estimates the chance of such an eruption at 1 in 730,000 per year. A small number? Maybe, but even the Titanic had a 99% chance of floating.
7 days after the eruption, Yellowstone could still be pumping ash into the air. 1,000 miles away, in places like Santa Fe and Kansas City, the ash would continue to fall and to kill.
Keep one low on your head.
The ash itself is deadly. Anyone living under the path of the ash cloud would need to protect themselves. That's because volcanic ash isn't really ash at all. It's rock that has been blown apart into tiny pieces. To see what makes it so dangerous, naked science put it under an electron microscope. Up close, the particles show up as minute shards of glass with jagged edges. If these get into the lungs, they can be deadly.
Yellowstone's not alone. The Cascade Range is a sleeping brotherhood of fire that feeds right into it, stretching from Northern California through Oregon and Washington into British Columbia lies the Cascade Range, a chain of volcanoes that have been quiet, but not still. And now they're making noise.
The Tieton River tumbles from high in the Cascade Mountains down to the sagebrush and lush orchards of central Washington. Everyone knows the spectacular cone-shaped stratovolcanoes in the high Cascades, but here in the Tieton River Canyon, there are stories to be told of huge cone volcanoes just west of Yakima, 4 of them, and a 5th volcano that used to stand at Goat Rock's Wilderness. The Cascades are a graveyard of old stratovolcanoes that have lived and died here in the mountains.
These mountains wear snow like a disguise, hiding fire beneath. Mount Rainier, towering over Seattle. Rainier is a glacier-clad giant. Its eruption would send layers of fast-moving mud flows barreling down valleys, swallowing communities like Orton, Enumclaw, and Pulop. Over 2 million people live in its potential path.
Less than 30 miles from Yakima, 4 cones once stood in this neighborhood, where today Rimrock Lake and the forested east slopes of the Cascades preside. A Mount Rainier-like volcano once stood right here. The volcano is gone, the lava flows are gone. The only thing remaining are monoliths down there above the lake that are part of the magma chamber from 25 million years ago. In the dark, the magma solidified. Diorite that's 25 million years old.
Mount St. Helens. She already erupted in 1980. She killed 57 people, flattened 230 square miles of forest, and darkened skies as far as Oklahoma. She's rebuilding. She's not done.
To understand just how big this eruption was, we compared it to the United States' biggest volcanic eruption in living memory. Mount St. Helens erupted in May 1980, blasting 7 billion tons of rock from the side of the mountain. Enough debris to bury Manhattan to a depth of 55 feet. The eruption was equal to 500 Hiroshima nuclear bombs. It flattened an area of forest 3 times the size of Washington, D.C., and sent ash 15 miles into the sky.
Mount Hood, Mount Baker, Glacier Peak, and Mount Shasta. Each of these hold the power to displace, to destroy, or to rewrite landscapes and lives.
A growing ground bulge detected near Three Sisters volcanoes, well, means that an eruption from this volcano might be imminent. And Oregon geologists are keeping a close eye on the ground movements in the Three Sisters volcanic region. And that's how they've detected the subtle increase in the rate of uplift in the ground near the South Sister volcano. We're going to go over all the data and all the implications now. Now, this is a rejuvenated uplift near the South Sister volcano, and you're looking at the Three Sisters here. Now, using satellite imagery and sophisticated GPS instruments, Cascades Volcano Observatory geophysicists have detected a subtle increase in the rate of uplift of the ground surface about 3 miles west of South Sister volcano. This is in Oregon. Even though there is uplift, the volcano alert level is and remains at normal, Three Sisters at the bottom here, as well as all of the Cascade volcanoes themselves. Now, data from satellite radar images show an uplift of around an inch, or 2.2 centimeters, about the width of an adult's thumb. And this has occurred between the summer of 2020 and August 2021, across an area 12 miles in diameter. GPS data from a volcano monitoring station near the center of the uplift measured at least 0.2 inches of uplift since August of 2021. Additionally,
the current signs coming from the Cascades.
Now, the good news is that Three Sisters hasn't erupted for about 1,500 years. Lots of other volcanoes have erupted in the Cascades in just the last 200 years, including Mount Baker, Glacier Peak, Rainier. We all know about St. Helens, Mount Hood even, Shasta and Lassen. All have erupted in the last 200 years. Now, is there any evidence that Three Sisters will erupt? Yes, it's uplifting now, and magma is being placed underneath of the volcanoes. So Three Sisters is going to erupt. Does it matter? Probably not. It only erupts at VEI2, going all the way back through the Holocene. In the last 10,000 years, these volcanoes only erupt at VEI2, so that's what we would expect during the next eruption. So nothing to worry about. Certainly something to go witness and enjoy the beauty of Mother Nature at Three Sisters, which will erupt soon in the Cascades.
Swarming earthquakes. Increased seismic activity has been noted near Rainier, Hood, and Glacier Peak. Volcanic gas emissions. Monitoring stations have detected heightened levels of carbon dioxide and sulfur emissions.
Seismologists observed brief bursts of small earthquakes in October of 2021, December of 2021, and then January 2022. Most of these shallow earthquakes are too small to locate precisely, but those located are inside the uplifted area. And you can see the uplift data on the top in the red line, as well as the seismic data below. And some sort of a kickoff event here in 2004, and a continuous rise in the ground surface with, well, quite an episode here. Now, uplift occurred in the same general area in the mid-1990s. And during the 25 years between 1995 and 2020, the area rose approximately 12 inches, or 30 centimeters. That's 1 foot, kids. Although the current uplift rate is slower than the maximum rate, which was measured in 1999 and 2000, it is distinctly faster than the rate observed for several years before 2020. The uplift is attributed to, you guessed it, small pulses of magma accumulating at roughly 4 miles below the ground surface. It's been accumulating now for 2 decades.
They called that volcanic breath. There's been hydrothermal changes. Glaciers are melting faster. Springs are shifting temperature. These are whispers from deep underground. Like Yellowstone, the chance of an eruption from a Cascade volcano may seem small, But history tells us eruptions here are not if, but when.
100 years ago, field geologists speculated that the distinctive Tieton andesite erupted from Mount Rainier. But recently, Forest Service geologist Darrell Gussie has traced the Tieton andesite on foot back to its precise source, deep in the remote Goat Rocks wilderness.
It took the older Tieton andesite lava flow about 12 years to flow from Bear Creek Mountain to Cowiche Canyon just outside of Yakima. The older flow was dated at 1.64 million years old, and the younger flow was dated at 1.39 million years old, a difference of about 250,000 years between the lava flows.
Those dates put us squarely in the Ice Age, where lava flows and glaciers were competing for space. The monoliths of diorite were so big that they held their own against the advancing glacial ice. They defeated the ice. Ice no closer to Yakima than Tieton Dam.
We are being warned by the earth, by creation, and by the Spirit. This is not a time for panic, but for preparation. Not a time for blame, but for building. And not a time for comfort, but for calling. We must educate. We must prepare our families, stock water, food, and medicine. Form community plans, strengthen our faith, and stay awake. Because when the ground begins to shake and the skies darken, it will be too late to wonder if the signs were real. So let us be a people who listen. Let us be a people who are ready. And let us be a people who stood, not in fear, but in faith. God is still on the throne, but the earth is groaning. So let us heed the signs and let us act. I hope you enjoyed looking at the Yellowstone and Cascade volcanoes. Have a good day, guys.